By the mid-1950s, with the advent of relatively thin aircraft wings, a new and dangerous phenomenon related to wing flexibility was being encountered. Many pilots were experiencing severe wing oscillations called flutter during flight, which threatened the safety of the aircraft. The need to better understand this new phenomenon led to the development of the TDT, or Transonic Dynamics Tunnel at NASA Langley. This new wind tunnel needed to not only test the elastic properties of aircraft, but also test a host of other aerodynamic situations in an effort to save lives. Early airplanes were built with materials that could easily withstand the relatively low speeds that aircraft were flying at that time. But as aircraft began using thinner wings with more powerful engines for high-speed flight, pilots began reporting encounters with flutter in some aircraft. There was very little data to explain this phenomenon at transonic speeds, so researchers at NASA decided to build a unique wind tunnel which could help answer some of the questions about this new phenomenon. This is where the idea for the TDT was born. The decision was made to convert the 19-foot pressure tunnel into the new, more modern TDT. Early in 1960, after years of intensive design and calibration, the world's first aeroelastic testing tunnel was ready for service. Unfortunately, fate had already selected the TDT's first occupant, the Lockheed Electra. After two fatal crashes of the Lockheed Electra, investigators found that in both crashes, the aircraft's wings had separated from the body of the plane due to violent flutter. A 1/8 scale model of the Electra, complete with rotating propellers, was quickly readied for the TDT's test chamber. As testing began, engineers found that the Electra's structural safety margins far exceeded its requirements. However, as the stiffness of the engine mounts were reduced, the torque of the engine-propeller combination led to a wobbling motion. The wrenching of the engine reinforced the wing oscillations until the wing fell off. The engineers had a term for this phenomenon: propeller whirl flutter. With this information in hand, all the engine mounts on the entire Electra fleet were strengthened, and the aircraft has been operating successfully and safely ever since. The Electra breakthrough was just the first of many successful experiments completed inside the TDT. Through its over 40-year history, the TDT has tested nearly every type of commercial and military aircraft in the air today, while also testing a myriad of other far-reaching applications, including helicopters, launch vehicles, and other aircraft designed to fly on planets like Mars. This unique facility continues to test boundaries while making flight safer for all of us.